Hello, this is Mr. Rasmussen, and welcome to Algebra 1, Lesson 82 on functions. Now, functions may look a little differently than what you're used to seeing, but think of function as a machine where you put one thing in and you only can get one thing out. This first part here has some equations, and we will put one thing in and get one answer out. This first part here, the f parentheses x, think of that as the label, not part of the equation, but the label that simply identifies this. Then if we want to find that f5, that basically lines up like this, where it's identifying the equation, and then any place in this equation over here where there's an x, we're going to put a 5 in and get an answer. So we have an x here, so we put that in such as this, and after we do that, then we would simplify the equation. 25 plus 5 minus 10, and then once we get that far, 25 plus 5 minus 10 is equal to 20, and we've solved that. So as we do those, remember this first part is not part of the equation. In the past, students seem to have gotten that confused a little bit. All right, so go and look at some of the examples there at the first part, and when you're ready, pause the video and try the two practice problems, and then check your answers with my work here. I'm going to work through those now. These ones are going to look a little different because instead of having a number that we're putting in, we're actually putting in another variable, which means our answer is going to be in an equation form and not actually to an answer like 20. So once again, let's take this. It lines up with the first part there. So any place that we have x inside here, we're going to be putting in m squared. So I'm going to write that in there. We have two parentheses. Remember, it's important to put parentheses in. Otherwise, you will get different setup and perhaps the wrong answer. So if I put it in there, it'll look like that. Let's remove the parentheses. In this case, since this is an exponent of an exponent, we multiply those. We get 2m to the fourth plus 3m squared minus 5. And I believe that is as far as we can go with that one. There's nothing that can combine in there. That is our answer. All right, let's look at the second practice problem. Once again, this first part here, this lines up with the x inside of this equation anytime x shows up when we're putting this in there. So that's going to be written as m plus 2 squared minus 4. And this m squared, that doesn't mean we just multiply those in. It actually means it's m plus 2 times m plus 2 that way. So let's multiply this out. We'll take this first term and multiply it in. I get m squared plus 2m. Take this 2 and multiply it there, plus 2m here. Take this 2 and multiply it by the other 2. Remember, both of them. Plus 4, bring this down, negative 4, add them all together, m squared plus 4m, and then you notice here my 4 and my negative 4 are actually going to cancel each other out, so this is my answer. All right, and that is the first part of the lesson where we have a function and we're simply putting in the number that corresponds to the label and corresponds to the x and solving. Moving on to the second part, we have identified domain and range. I wrote out function is mapping of one set of the domain to another set of the range. So if we think of this function as machine, the domain is the set of all possible values for x. So you think of your x is going this way and your y is going up and down on a graph. All the possible values for x are going to be your inputs to the machine, and what you get out of the machine or the answer are your y values. I think this is best explained if we start out with example 6. So I'm going to come back to those. Example 6 actually gives us a graph and asks us to write what the domain is and what the range is. So let's start with that one. So once again, the domain of the function of f is how far it goes on the x line. Okay, so we actually see here that these are solid lines, which means that it's not just integers, but it's all the numbers. So as we start writing this out, we're going to get x corresponding to the domain is the element of all real numbers. Okay, and then we're going to start on our left side here, and we notice that the furthest left any of this goes is at the -2. So we're going to put a -2 here, and then we're going to work to our right, and anything has to be larger than, such as this. We're not going to put an equal sign there because notice it's an open circle. So in this particular graph, it's anything larger than -2. We're going to put an x here in the middle because everything pertains, and then less than, and the farthest we come over here is a +3. And since it is a closed circle, we're going to put a line there. So x is anything larger than a -2, but smaller than or equal to a -3. And if you think of it, it's simply, if we were to draw something like that, you've already seen something like that. And we end it here with a bracket. Okay? The range is the acceptable parts up and down that it can go. So once again, these are solid lines. So we're going to put a y for the up and down is element of all reals, as you see there. And then we're going to start actually at the bottom and work to the top. So what is the furthest down it goes? Well, on the y scale, it actually starts at 0. So anything is larger than 0. Does it include 0? Well, we don't see an open circle, so yes, it includes 0. And then we put our y in the middle, and then it is anything less than. We go as high as the graph goes. Here, this one is only to the 3, whereas this one goes to the +4. So 4 is higher, and notice that this one is closed, so it does get the line there, and that's as high as it goes. It would look the same way as perhaps this if we were to do it in a straight line like you're kind of normally used to seeing. If this open circle were higher, if it were up here, then we wouldn't have the line down here. Okay, so I like to start with that because it shows you visually domain is simply how far right and left it goes, and range is simply how far up and down. Right and left x value, up and down y value. All right, let's move on then to example 4 in the lesson and work through that one. Now, I wanted to work through this one a little bit just because this is looking differently, and we'll use the graph to demonstrate. But it asks us to find the domain and the range of this equation here. Now, once again, this is just a label, and for the x, we're going to pick a value for that. So let's just say x is equal to 1. All right. So if we put that in there as 2 times 1, then our answer is going to be 2, and what we get out of it, our answer is equal to our y value. So our x is what we choose to put in, and then what we get out is our y value. So I'll write that again there like that. So if we graph that, x is 1 and y is 2, we got a point right here. Okay, let's pick another value. Let's go with, I'll do it down here at the bottom. Let's go with x is equal to 3. All right, so if I put that in there to my equation, 2 times 3 equals 6. Therefore, y is equal to 6. And if I graph that one, I come over to 3 and then up to 6. And there we go. So we see a pattern there, a slope of a rise of 2 and a run of 1. And if I will put a line through here like this. I wanted to demonstrate this. this line just keeps going this direction and keeps going this direction. Henceforth, what it's saying is that for every x value that can put in, whether positive or negative, you're going to get a y value. So what is the range? Well, the range infinitely goes right and left, and the domain infinitely goes right and left, and the range infinitely goes up and down. So how would we write that? Well, we simply write that as we'll abbreviate it. The domain is equal to, domain of f is equal to the set of all real numbers. Or the domain is equal to all reals. Or I guess we could write that as equal to, if we put it in little brackets there, x is the element of all reals, and there we go. And henceforth, the range is y, little bracket, is the element of all real numbers. And you can see that there in your book as they write it out. Let me show you that. Okay, so that brings me to the practice problems. And so I'm going to come here. All right, so there's practice problem C. And once again, I would suggest maybe pausing the video and working through these yourself, and then you can check your work and your answer with my answer just for the learning process there if you need that. Okay, so practice problem C asks us to find the domain and the range of the function of f. So once again, we have 3x. Let's pick a value. Well, if we were to pick a value for x, such as x equals 3, and we put it in there, 3 times 3 equals 9, therefore y would equal 9. And we see something very similar to what we just did, where for every x value, you're going to get a y value regardless of what the numbers are. So our answer to this one simply is the domain is equal to x as the element, this little weird looking like E is the elements of. Remember, sets have made up of elements. So all real numbers. And then the range is equal to y, which is the element of all real numbers. In other words, every real number, every number works inside of this. It doesn't have anything that it's limited like we saw in our graphs. All right, practice D is a little different. It's similar to the example in the lesson that is 0.5 that it didn't go through yet. A little different in regards to that. We have our equation as simply 2. Well, let's pick a value. Let's pick x is equal to 3 again. Okay? If x is equal to 3 and our equation is 2, do we have any place to put x in there at all? We don't. Henceforth, 2 is the answer, or y equals 2. Let's take another number. Let's say x is equal to 5. Well, if we have no place to put it in there, y is still equal to 2. So it doesn't ever change. And so, how would we write this? Well, once again, the domain, which is equal to our x values, is the element of all real numbers. There's nothing that confines that. All of them work. However, the range, y, is equal to 2. There's no other number for this particular equation that works. Every time you put any input for x, the answer is always the y value of 2. All right, and then we come to practice problem E. And this is like our first example there, so I'll work through that one again. Practice problem E. Determine the domain and the range of f. Well, let's start writing things out here. The domain is equal to x, the element of, well, we see solid lines here, and so all reals. And then inside the parameters, it's not just simply all of them, because we have some stopping points here. x to the negative fourth is not part of it. X to the seventh is not part of it. It's outside. So we're going to start on the left. And the furthest left that we go is negative 1. It's anything larger than negative 1. Notice an open circle, so no equal sign. And I'll put an x here, but less than or equal to, because it's closed circle, and that was on the 5. So there's our domain, the farthest left and right that it goes. Our range is equal to y, is the element, once again, of all reals, because solid lines. And then we'll start at the bottom, and once again, it's negative 1. And as we go up, it's anything larger than or equal to, y is in the middle, and then, very similar, larger than or equal to, the highest we go on this line is actually the 3. So we put a 3 here, and that is our notation there. And this is for this particular one where we have parameters, this is the notation I'm looking for in your answers. That brings us then to practice problem F, and I hadn't gone through any of these yet, so I'll come back to the lesson. And example point 7 in the lesson gives us a similar one here, where it says find the domain. I'm not concerned about range here. Find the domain of this particular equation. Well, this one does have something that we have to recognize, a parameter to stay inside. And that is that a number inside the square root cannot be a negative number. It has to be either 0 or larger. Okay? So what we're going to do is we're going to take this here, and whatever we put in here, okay, x minus 5 has to be anything larger than or equal to 0. It cannot be a negative number inside the square root. So if we write this, then we're going to solve this for x, meaning get x by itself. So we're going to subtract 5 from both sides. We now have negative x negative x is anything greater than or equal to, now is negative 5. And then once we do that, then we have a negative on both sides, and so we're actually going to divide both sides by negative 1, and we get x is anything greater than or equal to 5. So that's when we do that, now we take this part here, and we're going to put that into our answer. So once again, domain is equal to x, all the numbers, elements of all reals. Then our specific thing here, we're going to put, oh, I have an error. I have an error. I forgot something. Whenever you divide by negative, we got to flip our sign. So let me actually correct that here. Since we divided by a negative, it has to flip. There we go. Okay. All right, so then we simply point, right, let me back up a little bit here. We're working with an inequality. Anytime we divide or multiply by a negative, what happens, so since we divided by a negative 1 here, a negative 1, to get this to be a positive, this sign here, it was x is larger than negative 5, it has to flip. And so now if x is less than 5. So then we just simply take that and put that into our answer, such as this. And those are our parameters. All right, I'll look at the last example there in the lesson. And once again, these are kind of a little bit extracurricular. I don't know that you'll see those so much in your homework, but perhaps I want you to be ready for it if you do. It says find the domain of this function here. Now, inside the fraction, the only thing that we have to watch out for is x cannot be 0. That doesn't make sense to us and doesn't compute. Therefore, all the other numbers, whether positive or negative, do work. So this one is simply the domain is equal to x, the element of all reals, where x is not equal to 0, but everything else works. Okay, let's move on here, and once again, feel free to pause the video and work through the last practice problem F there and see if you can get it, as this one does look a little different and is a little bit trickier. All right, let me proceed here, and once again, this is in a square root, so whenever 3 minus x ends up being, it has to be larger or equal to 0. It cannot be a negative number inside the square root. So once again, as we set it up like this, we're going to get x by itself, subtract 3 from both sides. Negative x is larger than or equal to negative 3. And then if I divide by a negative 1 and divide by a negative 1, once again, x, my sign has to flip, and I get this here. Then I'm going to write it out because finding my domain is equal to, there we go, x is the element of all reals. All the numbers work except inside the parameters, except for, and I have to put that here, x, anything that x is less than or equal to 3. Let's see what happens if we were to change that. So x has to be less than, let's pick a number that's not less than 3. Let's put 5 in, for example. So if we have a square root of 3 minus an x is 5, well, 3 minus 5 is negative 2. It's a negative number, can't work. However, if we put 4 in, 4 is larger than 3. 3 minus 4 is still negative 1, doesn't work. However, if we put 3 in there, that's the largest number that can go in. We can still get the square root of 0, which actually is equal to 0. Then all the other numbers start to work. For example, if we go to 2, 3 minus 2 is equal to 1. Square root of 1 is 1. And 3 minus 1 is 2. Square root of 2. It all starts to work at that point. Okay. A little different of a lesson today, but I hope that helped. And if not, please feel free to contact me, and I can help you further on this lesson. Have a great day.